Okay, so I cannot switch the camera around here in mid-flight. So the volume, let's see if I can write upside down here. The volume for a sphere is 4 over 3. How does the 3 go upside down? Does that look right? Ooh. 4/3 pi, we know what pi is, times r cubed. 4/3 pi r cubed. That's the volume for a sphere. Let's see if I can do this. S, P, H, tell me if I'm doing this right, E, R, E? F-E-A-R. Oh, quiet. Okay, sphere, volume for a sphere. Nice. All right, so let's I'm going to spin this around so I can actually work on this. So the radius was what? 3.25? Yeah, 3.25. Okay, 4 over 3 times pi times 3.25 cubed. Okay, that's what we need to figure out. So let's see if that comes close to our expected volume for that tennis ball. Okay, so this is for the tennis ball. What do you get when you do that? And if you're wondering how to do the 4/3, you can just do 4 times pi times 3.25 cubed, and then all divided by 3. You can do that as well. So what do you get for an answer when you guys come up? What does it come up with?
143.
143? What'd you get? 143? Okay. And did all you guys get 143? Okay, so this is about 143 centimeters cubed. Okay. Well, that's a little bit different than our approximate 125, right? It's a little bit more. Now remember, I kind of had to squeeze this ball out a bit, so there was a little bit of water inside. And if we account for that little bit of water that was inside, then maybe it would, 125 that we measured would maybe go up another little bit. So anyway, so we're close. We're close. It's not exact, but we're close. Okay. Let's see if we can do the same thing for a pyramid. All right, so here we are. We're back again. We're going to do a pyramid, right? It's a square-based pyramid, and we're looking for volume. Now, we don't know what the formula is, but we're going to find out what the volume of this is, and we're going to use the same sort of thing that we did with the sphere. Now, the volume here has changed a bit, so this tennis ball definitely soaked up some water. So this is now, my best guess is going to be about 485. Ooh, 485. What's 125 plus 15?
15.
What's 125 plus 15? That's about 140, isn't it? So if this tennis ball actually soaked up 15 to 17 centimeters cubed, guess what? That puts us exactly at 142 or 143 that we calculated. So this tennis ball actually soaked up quite a bit of water. There's maybe some inside. So that means that our displacement from the first example was pretty good. So let's say we're at 485 here. And what I'm going to do is I'm going to put this pyramid inside here, and I'm going to poke it down. And this wood might soak up a little bit of water too. But let's say, without getting my pen in there, oh boy, I need to again. Okay. So let's see what we can do here. Okay, just barely submerged with very little pen. Oh, it's going to be tough. It's going to be really tough here. Okay, so let's say about there is 5. Oh, that looks like 550. 550. So 485 to 550 or so? Right? What's that difference? 485 to 550. Okay, 45 to, okay, 65 you said? 65. Is that agreed, the rest of you? Okay, so about 65 centimeters cubed. Okay. So this pyramid here, let's see if we can do some measurements here. Okay, so this pyramid is exactly 4.9. Should be by 4.9, shouldn't it? 4.9 by, let's see here, oh boy, by Yep, 4.9. So 4.9 by 4.9. Okay, so we've got 4.9 times 4.9. Okay, that's going to be the area of the base. Now, if it was a prism, we would just multiply by the height, right? It's not a prism. It's not a prism, but I'm going to record the height here anyways because that's going to be part of our calculation. And the height here is 7.6, I'm going to say. 7.6. Okay. And 7.6. Now here's the hint. We are actually going to be multiplying all those together. Length times width times height. Okay? But this is certainly going to be a lot less than the volume of the prism because it goes to a point. It doesn't go to the same base, right? So it's going to be less. Now, what is this number if we were to multiply all these together? What is that? So 4.9 times 4.9 times 7.6. What is that?
182.47.
So you said, sorry, 182 point what? 476? 48? Okay, let's just go 48. Okay, 182.48. Okay, and so that would be centimeters cubed, and that's for the prism, right? That's for this right here, the prism that has the same base. Now, what's the relationship between this and this? Can you divide this number by this number and see kind of what we get? What's 182 divided by 65? So how much smaller is this? 2.8 or so? 2.8 something? Okay, so 2.8. Well, if our estimation, okay, of this volume was just slightly off, do you see how this is kind of like a factor of 3? 2.8 is pretty close to 3. And actually, this is the key. So the volume of a pyramid, let me put another paper on here. The volume of a pyramid is length times width of the base times the height, all divided by 3. That is the volume of a pyramid right there. Length times width times height. So it would be the base length times width, and then the overall height from the base to the top.
Not the slant height?
Not the slant height, the overall height. Because, and we kind of figured this out again, it's not an exact science, because even this beaker is hard to tell exactly what the milliliters are, but this is a factor of about 3. So this was the pyramid, that's the pyramid, and this is the prism. Okay, so about a factor of 3. Excellent, excellent. Okay, all right, we're going to do one more. I don't know, hope you guys are liking this little demonstration. I'm not really sure if that's working out for you or not. Let's see. Oh, those aren't really comparable. Okay, we're going to do a cone. All right. You guys with me so far? Is this okay? We're going to do a cone. Okay, so here's the cone. Now, I want to find out what the volume of the cone is. So what I'm going to do is I'm going to find out what this base is. Okay, it's just easy for me to measure like this, I guess. So this base is, you want to write this down, it is exactly, going to go through the middle there, 5 centimeters, exactly. Okay, the diameter, how do you say it? How do you do a D upside down? 5 centimeters. Okay? So what's, the diameter is 5, so what does that make the radius? 2.5. Very good. Centimeters, okay. 2.5. Awesome. I'm a good upside down drawer, writer, I gotta say. Okay, so now we're not looking for surface area, right? Remember this? We're not doing surface area. Instead, we're doing volume. So let's see. Does this kind of resemble a pyramid, guys? Yeah. Does this resemble a pyramid? The only thing is that the base is not a square or a rectangle. The base is a circle. But you see how it kind of has the same general kind of shape? It comes to a point from the base. It squeezes up to a point here. So these are very similar, okay? So what we're going to do is I'm also going to measure the height here of this cone. So the height of the cone is going to be, oh boy, is going to be exactly, 7.5 5. 7.5.
That's the actual height.
Yep. Okay, so the height 7.5. Okay, centimeters, of course. 7.5 centimeters. All right. So if we were to find the volume of the cylinder is going to be pi r squared h. Are you with me there? Pi r squared h. So what would be the volume if this cone was actually a cylinder? What would be that volume? So pi times 7.5, no, sorry, pi times 2.5 squared times 7.5. So pi times 2.5 squared times 7.5. That's what I'm looking for right there. And what's the answer there? Anybody got it?
147.26.
So what'd you say? 147.26.
26.
Is that confirmed by anybody else? Yes, yes. Okay. Got 2 other witnesses there. That's good. Okay, so we're going to have this in mind. This is the cylinder. What about the cone? Well, let's get our beaker out, the big bad beaker. And let's see. I'm going to try my best here to see. Okay, so I'm going to tell you, yeah, we didn't lose much water with that pyramid. So I think we're still at about 485. Is that what we said? 45. Okay, so here's the cone. I'm going to put the cone inside here and see how much the water level goes up. Excuse me very much. I'm going to use my fork. I think that might help.
Yep.
Oh, I do have a fork. I eat.
That's contaminated.
It probably is contaminated, so who cares? You're contaminated. Okay.
Jesus.
All right. You've been washed clean by the blood of the Lamb. Okay, so we are at, okay, so trying to negate my pen being under the water and my fork tines, we are at about 5, I'm going to say 540, about 540, guys, 540, 540. I think that was right, 540, yep. Whew. This cone is, speaking of cones, we went out for ice cream last night. Yeah. To a new ice cream shop in town.
Oh, isn't that the expensive place?
Yes, the expensive place. Yes, Dandy's. Yes, it's the expensive place. It's really good though. My wife's boss's wife owns it. So yeah, I took my whole family out there. Insane amount of money. However, it was very, very good. Okay. So, what is the volume? Displacement volume. So what was that? What was the difference then? 540 minus. No, what was it? Wasn't it 485? 540 minus 45. What's that?
480?
No,
Should be about 55, maybe. So we're doing 540.
yeah.
No, we're doing 585. 585, and then all the way up to 640. What did that? Or was it 485? Sorry, 485 to 540. What's the difference there? So 540 minus 485. That's 40 plus another 15. That's 55. Okay. So 55. What's the relationship between 147 and 55? So do a division here. What's this divided by this? What does that give us? That gives us pretty close to what? 2.67? Okay, that's a little bit low. So our estimating is a little bit off here because yeah, if you round it up. So this factor should be 3 as well. So our estimating probably is a little bit off, okay? But excuse me, sorry. So this is not quite exact, but it's reasonable to understand that the volume of, I'll write this out here for you. The volume of a pyramid, volume of a cone is pi r squared h divided by 3. It's the same sort of thing as a pyramid, okay? What the volume of the prism with the same dimensions, height, length, and width, the prism, right, a cylinder with the same dimensions, divided by 3. That's how you get it. Okay? And we talked about the sphere too, 4/3 pi r cubed. So, okay, so here we go. We've got all 3 here, and I'll just wheel this back a little bit. So we've got a volume of a cone is pi r squared h over 3, or divided by 3. That's this right here. The area of the base times the height divided by 3. The volume of a pyramid, okay, if it's a square or a rectangle or whatever, it's the area of the base. That's what big B means in your notes as well. Area of the base times height divided by 3. So cones and pyramids, very much the same. The spheres, like the tennis ball here, really out to lunch. Hey, it's really different. But that one is 4 over 3 pi r cubed. 4 over 3 pi r cubed. Or 4 times pi times r cubed all over 3. Same thing. Okay, any questions? All right.